Biology chapter 18 theory video 14. We are going to discuss about Pearson's linear correlation. So like I said earlier, if the data collected are continuous variables and they show a normal distribution, we can use this. The again the correlation will vary between +1 and -1, +1 being a positive correlation and it is going to be strong, and the -1 is going to be the negative correlation, and 0 means there wouldn't be any correlation, and if there is no correlation we don't actually calculate the correlation as well. So, but in this case, the calculation method is going to be a little bit complex, and like I said, it is not going to, they are not going to ask you to calculate the correlationship, but they will give you the details and ask you to explain how it is done. So again, what you do is, you just like in the earlier situation, you draw the scatter graphs, and the variables can be put into any of the two axes, and it would not make any difference. And if there is if the points fall close to one another, then obviously the correlation is going to be really strong. But if there is if the points are varied, or points are not falling at the same point, then it is going to have a negative. There wouldn't be a correlationship. So here a test was done to find out if there is a correlationship between the cracks on the bark of a tree and its circumference or the size. So these details were taken, these measurements, the circumference of the tree, again the mean width of the crack was taken, and now to find out if there is a correlationship, this particular equation has been used. Once again, you have to remember that this correlationship, the equations will not be, if you have to calculate them, it will be given. So you don't have to by heart these equations, but you need to know how to use these and what exactly to do. That is, you have to explain that the scatter diagram needs to be taken, and if the points all lie along the straight line and very close to it, then it would have a strong correlation, and if the correlation coefficient is close to 1, then it would have a again it would have a strong correlation. Like that you should be able to explain. So in this particular situation, what has happened is the correlation coefficient was calculated to be 0.79, and you can see that it is quite strong correlation. So that is how you do it. Let's write down a note on this before you go to question number 14. Pearson's linear correlation. If the data collected are of two continuous variables and if they lie normally in the distribution, we can use Pearson's linear correlation to find the coefficient. The values obtained would be between +1 and -1, and there would be a strong correlation if the variables appear close to the straight line. Close to the straight line. The variables can be plotted on either axis. It would not make any difference. And if this relationship is not linear, correlation coefficient is not calculated, and we need to make sure that the variables show a normal distribution before we decide to use Pearson's linear correlation. I hope you understood. Please do question number 14. if you have any doubts or difficulties, please let me know.